So we got ourselves a 454 here that needs our help. And so what we're starting with is a 30 thou overbore 454 block. It's a 2-bolt main with studs. We got ourselves a forged crank. We got some forged SRP pistons and Eagle H-beam connecting rods. And basically this poor engine just isn't wearing very good. Or it's wearing and very good. Depends how you want to look at it. But we got a bunch of skirt scuffing on every single piston, both sides. We got bearings that are showing signs of quite a bit of debris went through there. The crank shows signs of scuffing and picking up material from the bearing. Lots of scratches in here. I'm going to say a lot of debris went through this engine. We got some contact spots in the cylinders where it looks like the pistons were rubbing. Got a little bit of wear on the cam thrust face here. And I don't see any line honing marks, and we got main studs in here. So in my experience, going to a higher load fastener like this usually throws those bores out a bit, some more than others. So I got this snap-on dial bore gauge set up to the piston diameter that I measured directly from the pistons. And you know, at the top of this cylinder here, I get as low as 2 thou clearance, piston to wall clearance, and at the bottom here we're getting 3. So you know, that's pretty tight. Yeah, we're as low as 2, 2.5, and you know, 3. And the worst part is this is the looser side. If we come over to the tight side here, you know, we're 2.5, we're down to 2. That's 2 thou piston to wall clearance on a forged SRP piston. That is typically not the sort of clearancing that they recommend. At this point, it looks like I could buff these pistons off, throw this thing up in the honing machine and hone this, you know, give it some clearance that it wants. And not only will we clean this up and give it a little more clearance, but you know, a cylinder like this will look like a brand new cylinder when I'm done. I've got one of my smaller diameter Starrett dial bore gauges set up to come in here and check the lifter bores real quick while I'm standing up on the end like so. So I'm checking at the top. I'm turning sideways to get past the oil feed hole, and I'm measuring at the bottom as well. Now another thing I need to come and check is going to be my deck height. I want to make sure that rotating setup fits in this block correctly. So I've looked up my compression height on my pistons. I got my rod length and my stroke length. So I have a theoretical zero deck height number, which is 9.78. And now I just want to come in here and take a quick measurement and just see how well that rotating assembly was fitting inside this block. So just to get a quick idea of what my deck height is, I'll just come in here and take these dial calipers like this. I will find the absolute tightest spot, and I'll take that number and I'll add that to the radius of my housing diameter here. And already calculated that in, so we'll just take that plus 8-inch 322, 8-inch 322 equals a 979 deck height. So that tells me that right now on this front hole at least, that piston at TDC was sitting in the deck about 10 thousandths. From what I can tell, whoever squared this block actually did a pretty good job too, because it's or at least it's nice and parallel to the mains. We weren't actually checking squareness, but I know that rotating assembly fits in that block. So I've gone ahead and set up my sun and dial bore gauge here, and I've set this so that 0 would be the low limit, and on this front one here, right off the bat, we're measuring, you know, close to 2 thou plus 2. So plus 1 would be the high range, and that would be acceptable. But we're actually plus 2, which means we're 1 thou over the high limit, which means we are absolutely out of spec. Now I'm going to pop off this first main cap here and then slide the old bearings in real quick. And then get it torqued back up again. Then I'm going to take a measurement from the front journal of the crankshaft. And then I'm going to set my dial bore gauge to that measurement. So now that I got the gauge set up to the exact diameter of that front crank journal, we can see what kind of vertical oil clearance we're getting. And right off the bat, I'm measuring, you know, upwards of 4.5 thou oil clearance. And that's a fair bit, you know, between that excess oil clearance and what looks like a lot of debris went through this engine. I'm going to say that's why the bearings and the crank look the way they do. So in the end, we got something that I'm going to be able to kind of buff up nicely. First thing I got to do, I got to send this out and get this thing align honed. We got to get these main housing diameters where they're supposed to be, all nice and aligned with each other, round, and that's the first order operation. I don't own that machine yet, so I'm sending this out to a neighboring shop, and we're going to drop that off right away so they can get on that for us. I noticed too, we got steel plugs in here. They're building this for a street strip project. They're going to run this down at the quarter mile we have here in Mission, at the Mission Raceway Park. And you know, we're not allowed antifreeze and coolants on our track, and I haven't actually been to any track that allows that. So, you know, if you're just going to be running straight water in your cooling system, yeah, you probably definitely don't want these steel plugs. I'm just going to take this main cap to the back now. I'm just going to come up in here with my grinder, and I'm going to relieve this sharp entrance here and all this nasty cast, and just kind of make this look a little better. It doesn't need to be this super port and polish job, but we're just going to tidy that up a bit. And without getting carried away, I just did a little cleanup, and I do this before I send it to line hone, because sometimes the line hone guys, they machine this side of the cap as well. And this is what I'm talking about. They're going to cut the cap, is when they do their line hone, they're going to cut this portion of the cap, and they're going to sit it in a machine just like this. They actually have the exact same one, and they're going to sit it up in this machine just like this, and they're going to run this over this grinding stone, and they're going to grind this flat, and they're going to grind it so that this radius here shrinks, so that when they torque it all back up, the diameter of the bore is now smaller than what it should be, and they're going to align hone it straight and get to the original spec diameter. Now before they just drop that in there, they usually stick them in sideways, and they machine this face a little bit just to make sure this face is square to this face. So they sit it here and they grind there in hopes it's square to that. And I noticed too that quite often on their Chevy main caps with the oil pump mount just like that, they also drop it on there and they give that a zing flat.